So thanks, Kai. And hello, everyone. I hope you had a good lunch and are not too tired after it. So I'll be talking about OSGi best practices. Funnily, when I looked at how often I've been at EclipseCon, I looked back into my presentations and found that I actually did the OSGi best practices presentation, not on EclipseCon, but 2012. It was a bit different, but interesting how things change. So it was all about blueprint then, and nowadays it's a bit changed. So a bit about me. I'm working as a computer scientist at Adobe in the Experience Manager team. Basically, it's a content management system for big companies that we produce. And this system is based on OSGi. This is why we are into that technology. And I'm also a member and committer at Apache and work on a few Apache projects. You can also follow me on Twitter or at my website. I will later post the slides and the demo code on Twitter, so you can have a quick follow-up on this. And here you see my family. So I got 2 daughters and a wonderful wife. I'm quite happy. So I would like to take you on a journey of how to create an application from the start of setting up the basic Maven modules, creating the bundles, and then into best practices of start levels and DS best practices, into the last step of going from your bundles to a full application. So how to combine the idea of loose coupling at design time with the requirement that you want to have to not have too much effort on application assembly, because when things are so loosely coupled that you don't find the things together, then it's also not really good. It might be a nice architecture, but the one who does your assembly, mostly yourself, will not be so happy. So I'll look into that too. So the first thing is about creating bundles. This is always the first step in OSGi. It used to be quite difficult. Nowadays it's rather simple, and with some recent improvement it has become even simpler. So most of you might be already familiar with the Maven bundle plugin and how it is used in many projects already today. The downside is a bit that you have a detailed setup in the POM, often at least, and many also have explicit export declarations and defined versions in the POM, and this is also a bit error prone, and it tends to break when you do Eclipse-based or IntelliJ-based refactoring. So this is one of those typical configurations. What I want to highlight here especially is this extensions true. This is kind of the default mode that probably everyone learned about the Maven bundle plugin. It means that it adapts the whole Maven lifecycle to get itself into all the different places where it wants to do something, which is convenient because you don't need a lot of additional configuration. But it is not really good for your build. For example, your modules have to be of type bundle, which is sometimes a bit strange when you then create a dependency for that project. Sometimes, for example, if you use the Eclipse Maven support, it creates a type bundle dependency, and this doesn't even work. So you have to remove it again. And it's also very bad if you have builds that are not mainly OSGi, but rather some library that also wants to play in OSGi, but is not mainly for OSGi. Then those people really do not like to change their whole build into type bundle for every module. And so this is not really recommended anymore. The other thing is inside this instruction space, you configure the whole stuff, or can configure it. And this is an example from Apache Carafe plugin, or module, the diagnostic plugin. It's a bit older, and it is kind of the worst case that I found, just to demonstrate what people sometimes do. You can have the whole export and import adaptions and private packages declared and an activator, and all this is just text. So when you change your code, it will not adapt. It will stay the same and break your, hopefully your build, maybe only after you install it. So the recommended way is you actually can also do that with a Maven bundle plugin, but I even like the BND Maven plugin a little better. Both are based on BND, but have slightly different defaults and ways to configure. So there, it is much less intrusive. It does not change the way Maven works. It just is executed in one step and creates the manifest, and the jar plugin then has to be configured to just take that manifest and put it into your jar. And so this is a little bit more XML than for the plain Maven bundle plugin with this where it changes your build, but it is much less intrusive in the end. So your build is just a really normal Maven build then, and especially when you put this into something that is not mainly OSGi, you don't hear complaints. Maybe sometimes people forget the jar plugin and it just doesn't work, but at least it doesn't break their build. So I did not put the whole XML into the slides, but you can look into the example code. The nice thing is you put this only in the parent. So normal projects with the Maven bundle plugin had this declaration of the Maven bundle plugin in every single module, often with different configurations. This is not really a good idea. So this you put just in the parent, and then all your submodules are automatically OSGi bundles, and for the most cases this is only thing you have to do. So the idea then is, of course, I have to define my exports in some way, and maybe additional requirements that the bundle has, or capabilities it offers. And this you can all tune with annotations nowadays, so you normally don't need specific configurations anymore. And the imports are always handled automatically. You only rarely need to adapt them for special cases. You can also use such a bnd.bnd file to do your specific configs if you need them. An ideal project normally just can skip that file. So this is how you export a package in the modern way. You just use two annotations that are in the OSGi spec. The add version annotation and the add export annotation. I typically put these dependencies to enable these annotations also in the parent, so every module just has them available, so it's really easy to use. What you might spot directly is you export a version ideally directly with a package ideally with a version. This might sound a bit inconvenient at first because every package could have a different version, but actually this is the way how you keep your software stable. You try, of course, to do the minimal changes to keep your users compatible and happy, and versioning by package allows you to do that in a much better way than the coarse-grained versioning on the bundles. And luckily we even have support to automate that. So this is all about the idea of semantic versioning. I hope this is a little bit known already. I will not explain how it works in detail. It's just mainly if you have a compatible change, you increase the minor version. If you have a breaking change, you increase the major versions. And if you don't have anything changed, then this version should not change, even if you create a new version of your bundle, because your clients should not be affected by the problem or by the changes. So of course, managing those versions by hand is really hard and not recommended. So the idea is you configure the semantic versioning plugin also just in the parent, and the default setup is it always compares your current version of the code with the last release. You can also tune this. You can switch it off sometimes if you know what you do, or you can say compare to a specific version. But by default, you just let it do its work, and it will compare your newest code with the released code and tell you for each package if you need it to change it and even what new version you need. So you just let your build run. If it fails, it tells you, please change the version of the exported package to this number. You change it, the build works, and all is fine. So it's really easy to use and helps you make your software very comfortable for your users, because they ideally very seldom have to adapt to changes this way. So the next thing is about start order and services, something that I recently read on the OSGi dev mailing list, that it even found entry into B&D tools, where they a long time did not really want to introduce this, as some people really seem to need that. But what I would like to explain a bit is why it's bad and how you can avoid it. So the question is, why do the OSGi experts normally tell you that start orders are a bad thing? And so the one thing about it is, when you have a start order, maybe even each bundle its own start level, it means your system can only start exactly in that way. So this basically narrows the way your system can optimize itself and be quicker to start up, because you tell him exactly each baby step to take, and this is not a good idea. And the other thing is, when you have a dynamic system, even your system is really dynamic at production time even, or just for development because you want to run your system and do a small code change and continue debugging with that change, then you will install bundles at runtime. And this whole start level setup is really only for the initial start. It will never work when you install things later. And if you rely on these start level setups for your whole application, then it really tends to break if you install any bundle or uninstall any bundle at runtime. So not relying on start levels makes your whole system more resilient to changes. And the last thing is, you can easily introduce deadlocks, like if you have a bundle at start level 2 that needs a service that only comes up at start level 3, the system will hang forever, because it cannot know that if it would go one step further, the problem would be solved. It will just blindly wait for the order you gave it. Yeah, so the idea is, instead of those specific start levels, you should just basically install all the bundles, resolve them all together, and then start them in any order, and the system should kind of figure out itself how to bring itself up in the best way, and this is done by using services. So instead of saying, I rely on starting after that bundle, you just, for example, can use a service dependency on something this bundle offers, and then you know, only when this service came up, I will come up. So the question is, why do people use start order at all? And the typical thing is, the code requires the system be in certain state. And sometimes this is just something, one bundle changes a static variable in some place, and the other bundle needs that for a static factory or something. This is never a good idea in OSGi. So your dependencies should always be on the level of services, and this makes it better. So only at first the start level looks good. If you use it in practice and your system grows, it's becoming worse and worse. And this is also something you see a lot, just people using the plain OSGi APIs to use the bundle context to get a service reference and then get the service and use it. Looks easy, the easiest way to do that, but it tends to break. And then people say, oh, OSGi is not reliable, I get null pointer exceptions, but this is normal because OSGi is a dynamic system, so getting a service at a certain point of time can work, but does not have to work, because the system can be in change, during a change, at any time. Even at runtime, you can install and uninstall bundles, and then it's just normal that services come up or go down. So the first thing is, after get service reference, you can have a null. After context get service, you can have a null, and you have to first check for these nulls. But the bigger problem is, even if you do nice checks, you will not have a null pointer exception. But now you know there is null. What do? I mean, you want this code to run. You need that service. And so the typical thing is, yeah, you try it again. You put a loop in there, and after some time, you break with a timeout. But this is not a stable thing, because even maybe you uninstall a bundle, and it's uninstalled for half an hour. You run into timeout, and your bundles will not recover from that. So this is not the way this can work. Then people think, there is a newer API, the service tracker. Maybe it can solve that. And to be fair, it can solve that, but not in the way people use it normally. Because if you use the service tracker, you can say, I want to track this service, maybe even with a filter. That's all nice. But then many people just do get service, or even the variant with a timeout. That's all nice, but when the timeout comes, you're again broken. And so the only way you really can use the service tracker, and I explicitly did not put it on the slide so you don't remember it hopefully, is you can override the adding service and removed service methods, and you can basically bring up your own code only in the adding method and destroy your class or deactivate it with some call in the remove method. So this works, and I also used it a lot for implementing some spec or something like that, where it's really, really low level. But at application code, this is not what you should do. So instead, we need something reactive, and we need something that scales. And the big problem with service tracker is it does not really scale if you have 5 services to track, because you have to cascade these service trackers. And this is not really nice to do. So basically, this gets us into the declarative services space. There are a few dependency injection frameworks in OSGi, but the easiest to use and the most kind of dynamic one that copes with the dynamics of OSGi very well is declarative services. And this is how you write such a component. Basically, you annotate your class with add component, which means this class is not managed by me, it's managed by the system and or by the declarative services runtime in effect. And it will come up when all its dependencies are met. Especially this is the service dependencies. At reference means I have a mandatory reference to a service, and this is fully dynamic. This means when the service comes up, or when all my mandatory dependencies are up, only then my service will start, or my component will start. And then the activate method is called, where I can, for example, spawn a thread or something to do something in the background. And in the end, the deactivate method is called. So when any of those mandatory services go away, I can, in that case, for example, when I spawn the thread, I can stop this thread again. And apart from that, I have an easy time, because these services, as long as my component is in between this activated and not yet deactivated state, I can freely use the service and don't have to care about the dynamic nature of OSGi anymore. So one thing about declarative services that took me quite a while to understand is, especially when you come from the Spring world, we have those beans that are internal to an application context. How do you do something that is needed inside your bundle but should not be exposed to the outside world? Because DS cannot have something like beans that are internal. It can only have dependencies to services. And so the question is, how can I express an internal dependency with a service? Funnily, it's pretty simple. You just use the service class from a private package, either the class itself or an interface, how much you want to make it loosely coupled inside the bundle. But as it's a private package, no one else in the system will see this service, and it is in fact a private service for your bundle. Another thing that easily can go wrong is you have these activate methods, and maybe you will want to do something there, like ask for a web service for something or load a file, and these operations can easily block. And this is something you should never do. But the question is, how would you do some blocking operation that takes a lot of time, possibly, and that you need in Activate before you expose your service to anybody else? And took me a while to find a halfway nice solution, because this is not natively supported by declarative services. So I used a completable future, and I supply async, this long-running task. This is here in a method, and then I do something, and in the end I register the service of my component, and this way this service of my component only comes up when my initialization is really done, independently of how long it takes. And then at deactivate, of course, I need to cleanly unregister the service, but of course only if it's registered. And this can also be nicely done with this future. So this returns a future, and then on the future you can say then accept async. So as soon as it was registered, it will be unregistered. And so this solves a pretty difficult timing problem. Hopefully. Tim probably can tell me that it's broken.
Then accept async, because that will only clean up if the completable future succeeds. If it fails with an exception, but the service has already been registered, you need to make sure the cleanup always runs. So
yes, but as the service is the last thing to come up, hopefully that will never happen. But
it's better to, so if you were using promise, it would be effectively an on resolve. You would just always do it, or at least always attempt to do it.
So yeah, maybe good improvements. So if you have that somewhere as an example, I can adapt the example code so people can later show that. I was almost sure that if you are in the talk, you know that's also not completely correct.
It's just worth flagging that any time you manually take control of the registration, you lose the DS will automatically do it for you. So
yes, unfortunately. So maybe that would also be something for a newer version of DS. I hope at some point it will have support for these long-running operations at Activate, because as you see, it's so easy to get this part wrong, and I really did my best. So now this thing about your architecture of your application, you of course want to have a loose coupling between modules, but it shouldn't be that loose that you can't find all the pieces together anymore. And this is, has been a big problem in OSGi. So loose coupling was always a big strength of OSGi, but it was notoriously difficult to, in the end, assemble your application with kind of minimal effort. This application assembly was always the difficult step in OSGi. Creating your bundles was not really that difficult. So loose coupling on the one side is you want to depend on interfaces instead of implementation, and ideally in that way depend on services based on interfaces. And even one step further is the whiteboard pattern, where you don't depend on some service. Instead, you offer some service with a well-known public interface, and some other service picks up your service that comes up and does something with it. The most well-known one is the HTTP servlet whiteboard, where you offer a service as a servlet, and the HTTP whiteboard will pick it up and publish it to its web server instance. And if your service goes away, it unpublishes it again. But the big problem with these whiteboards was always that it's very easy to not install that whiteboard, and then your application comes up, no single error message, it's just nothing happening. And you wonder, what's wrong? I get no error. And also at assembly time, I get no error. And the question is, how can we make that better? On the assembly side, we have the requirements of someone who does operations or assembly. he has to determine a list of bundles to bring up, and that with minimal definitions. Because if you have too much definitions, too much metadata to define how to bring up your application, it will also be kind of unstable. When you do changes, it will often have to also change the assembly. So ideally, you want as few things defined at assembly time as possible, and still it should be easy to determine your full list of bundles. So this is the example of a kind of traditional whiteboard. You just have a declarative services component or any other way to offer your service. You tell it which service interface to use, the Servlet API interface, and you give it the property of where to install your servlet in the server, and then you bring up your service. So from the loose coupling side, this is all great already. It's maybe a bit inconvenient to have to remember this exact property name, but it's not so bad. But for assembly time, it's problematic because there's no information in the system that this requires the whiteboard to be present. It can fully run without the whiteboard. It will just not do anything. And normally this is not the intention. If you use such a servlet, you also want to see it. So the newer version of OSGi, R7, has special annotations. So the first part, component service, is the same. But then instead of specifying this special property name, you use an annotation that already gives you the convenience of not having to remember that name. You have nice completion if you have the dependency to the jar that provides this annotation. So it's already at development time more convenient, but hidden behind the scenes, this annotation is not only defining the property, it's also defining a requirement, which helps the resolver to assemble your system. So if you do this and you use the resolver to assemble your application, it will tell you, oh, you're missing the whiteboard service. Your application is not complete. And so you can never get into the situation that your system comes up, but nothing happens. The same is actually true for using declarative services in general, especially in Apache Giraffe. It's a very common thing that you install something that uses declarative services. You forget to also install the declarative services runtime, this SCR feature, and simply nothing happens. No error, nothing happens. And this is very, very confusing, especially for people who start with it, but I also get confused again and again by it. So also there, for declarative service, the same idea is happening. When you are using declarative services, then the build will create a requirement for the declarative services runtime, and your system, if it uses the resolver, will at assemble time make sure that it's also installing the declarative services runtime. So basically the idea is use those new annotations and your system will have a lot more information to make it a complete deployment automatically. And the way this works is basically with a repository. A repository is a list of bundles that might be installed, and then you have initial requirements. You say, for example, in my example code, I just put my bundle there and say, I want this bundle to run and everything it needs. And then you let the resolver work on that, and it takes as many things out of the repository, as many bundles, into the list of bundles to start, so your application is working. And the nice thing is about those annotations, like the whiteboard servlet pattern, these are predefined, but the system is made in that way that you can define your own annotations for your own stuff. You can create your own annotations that also define properties and also requirements and also capabilities if you want. So you can use the same system to bring up your stuff in a very special way that only you can define. So this is how that works in BND tools. Luckily, thanks to Tim and Ray, there are now Maven plugins for the whole BND lifecycle process, like creating bundles, creating indexes, resolving your system, exporting your system into a nice starter. This is also integrated into the Maven run, and you have, at least in Eclipse, also a nice UI. So this shows the repository. In my example, this is just based on a POM file. In the POM file, you just declare all the dependencies and its transitive dependencies to give it a list of bundles. Then, in my case, you just, in the real example, it needs 2 bundles, the backend and the UI, and all the rest is figured out completely automatically by the resolver. You can click resolve here and directly start from Eclipse. You can directly debug into it in Eclipse, or you can use the Maven run to do it completely on the build server without any human interaction. So this is the main part, and as I'm quite good in time, I cannot present more. I have here, if you look at the slides later, also some backup around OSGi class loading. Maybe one simple thing the resolution of the class loading, in fact, the thing about class loading in OSGi, it looks very complicated, but in effect, a class is always loaded by the class loader of the bundle where it resides. If you don't tweak the class loading, this is the simple truth. It just looks where is the bundle located, and by all those delegations happening in OSGi, it will be exactly from that class loader. So there is no real magic happening. It's just coming there where you expect it to come from. So far? Any questions?
Yes, regarding that start level and so on. So for R7 it's clear I can define my own notation and so on, right? And unfortunately I have some customers and I need to downgrade to something that probably doesn't support R7. And the only thing I found is that I need to set up start level for one bundle. Yes, but I don't have our idea. Probably you can say what I can do before.
So what sometimes works is simply creating a, so this whole OSGi R7 stuff about these annotations and requirements capabilities, this is only a resolve time thing. It will not help or fix the start level problem. It will only make it easier to assemble your application. The whole thing about start levels can be solved with service dependencies. So you have to think about your bundle that needs that start level, and can it maybe export a service at that point when it's ready that you can depend on in other bundles, and that can work.
Yeah, you know, like in Equinox implementation, they need to have at least one bundle, like extension registry bundle, to be started early to start caring about all the others. So for problems like that, do we have another solution except start levels?
The only real solution are service dependencies. It might be a bit inconvenient though. If you have one bundle that you want to make sure that is there, and all the others need it, then they all need a dependency on some service that is offered at the right time, when it's there.
I understand, I need to spend another.
But it's not easy.
Another night trying to understand why this is empty.
An example is like the splash screen. So that's something that you want to happen right at the beginning.
Mm-hmm.
But it's not going to have a service. I mean, what service can a splash screen offer? So how do you make it run before everything else?
I think for a splash screen, really the question is if you want to do that all in one OSGi startup. I mean, a splash screen only comes at the start, so why not have simply 2 mini applications? One for the splash screen, and once this is through, you start the real OSGi application. I think for a splash screen, I would not try to do anything magic.
Actually shows you what plugins are being loaded. So.
But even that can work.
So that's really part of the launching of the framework then, and the launching of the framework is able to see what's happening in the framework. Right.
Yes,
so
yes.
The splash screen there isn't something running in OSGi, it's something that's starting the framework.
Exactly. I would also recommend exactly this.
All right, I think we need to stop here. Thanks.